So we are now done addressing our first goal for this discussion, which is for you to be able to explain the definition of bridge engineering, as well as for you to be able to explain the importance of the study of bridge engineering. So we are now done addressing those two goals for this discussion. So we will now move on to our third goal for this discussion, which is for you to be able to state the origins of the modern highway bridge. So before we start on studying the bridge engineering that we have today, before we start to study the modern highway bridges that we have today, it is worthy to look back, to have a quick look back on the brief history of bridge engineering, especially how the modern highway bridges that we have today came to its conception as what it is today. Usually, a discourse on the history of bridges begins with a log across a small stream or vine suspended above a deep chasm. This preamble is followed by the development of the stone arch by the Roman engineers of the 2nd and 1st centuries BC, and the building of beautiful bridges across Europe during the Renaissance period of the 14th through 17th centuries. Next is the Industrial Revolution, which began in the last half of the 18th century and saw the emergence of cast iron, wrought iron, and finally steel for bridges. So every time we talk about the history of bridges, every time we talk about the history of modern highway bridges, we usually start on the story of having a problem to on how to cross a small stream of a body of water, like for example a river. So before, when the bridges are were not already invented, when we encountered an obstacle like a small stream and we want to cross that small stream from one side of the stream to the other, we usually use a log or a trunk of a tree for us to be able to traverse that small stream from the one side to the other. So before the invention of bridges, the bridges that we use were usually a log or a trunk of a tree. We are placing that log across the small stream, and then uh, that is where we uh, cross the small stream using that small log. Or usually, if we don't have a log, if we don't have a trunk of a tree, but there is an available vine that is suspended on very large on very large trees, we usually use them as well for us to be able to traverse a some obstacle on 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 a particular location, like again like a small stream. If we have a suspended vines there, we usually use that vine to swing back and forth to for us to be able to traverse that small stream. So that's usually where the history of bridges starts, to the use of a log, to the use of suspended vines as our way to traverse an obstacle. So that's where we usually start the history of bridges. And then after that, it is usually followed by the development of the stone arches that were attributed to the Roman engineers of the 2nd and 1st centuries BC, as well as the beautiful bridges that were made across the Europe during the Renaissance period. So those were the development of the bridges that we have today started until the Industrial Revolution, which began in the last half of the 18th century, where they utilize the use of cast iron, wrought iron, and finally steel as a material to build a bridge. So usually when we talk about the history of bridges, those are the records that we usually talk about, starting from utilizing a log or a trunk of the tree or a vine suspended on a tree, to the stone arches of the Roman engineers, to the beautiful bridges across Europe during the Renaissance period, until the Industrial Revolution, where we already utilize the use of cast iron, wrought iron, and steel that we still use until this day. So just to have a quick look on the development of modern highway bridges, let us just have a quick look back on the bridges that we have through the years, starting from the stone arch bridges made by Roman engineers. So, stone arch bridges look something like this. So, stone arch bridges are obviously made out of stone, made out of stone that were shaped as an arch like this. The Roman bridge builders first come to mind when discussing stone arch bridges. They utilized the semicircular arch and built elegant and handsome aqueducts and bridges, many of which are still standing today. The stone arch has been around a long time, and how its form was first discovered is unknown. But credit is due to the Roman engineers because they are the ones who saw the potential in the stone arch, uh, develop construction techniques, built foundations in moving rivers, and left us a heritage of engineering works that we marvel at today. So we usually attribute the development of stone arches or stone arch bridges to the Roman engineers, who were the first ones who saw the potential to the use of stone arches as a material for a bridge structure. And and as you can see, until today, the stone arches or the stone arch bridges that were made by Roman engineers are still standing today. So you can see there how marvelous the structures that were made by the uh, engineers of long ago, because the structures that they had engineered before are still standing until today. Although at some point it's kind of ironic because today some of the bridges that we build today uh, usually usually have a shorter useful life compared to the bridges that were made long ago by people, by engineers who were not so modernized, who didn't have a modern technology to use to build their bridges at that particular time. It's kind of ironic, although we can still marvel on how the bridges of long ago were still standing until today. So another bridge that were made through the years are the wooden bridges like this on the picture. Early bridge builders began their careers as millwrights or carpenter mechanics. They had no clear conception of truss action, and their bridges were highly indeterminate combinations of arches and trusses. They learned from building large mills how to increase clear spans by using the king post system or truss beam. They also appreciated the arch form and its ability to carry loads in compression to the abutments. This compressive action was important because wood joints can transfer compression more efficiently than tension. So after the Roman engineers used stone arches as their bridge, the use of the use of wood uh, uh, were developed because most of the bridge builders before were actually carpenter mechanics. So most of the time, the material that were readily available for them, for the bridge builders of that day, are just wood or woods coming from trees. So with that available material, even with no clear conception of truss action, those bridge builders started to build wooden bridges that were made out of wood. So you can see here the materials or the members of the bridge were made out of wood. So these bridge builders of long ago uh, found the usefulness of wood in resisting compression more than the resistance of a wood on tension. So they utilize that ability of wood to resist more on compression forces than tension forces uh, by utilizing them as the members of the truss that will hold the bridges that they had built on that day. So the next uh, historical bridges through the years. The next bridge that were developed through the years was the or were the metal truss bridges like this one. Wooden bridges were serving the public well when the loads being carried were horse-drawn wagons and carriages. Then along came the railroads with their heavy loads, and the wooden bridges could not provide the necessary strength and stiffness for longer spans. As a result, wrought iron rods replaced wooden tension members, and a hybrid truss composed of a combination of wood and metal members was developed. As bridge builders' understanding of which members were carrying tension and which were carrying compression increased, cast iron replaced wooden compression members, thus completing the transition to an all-metal truss form. So the wooden bridges that were built before by bridge builders were actually good because the traffic that they were supposed to carry at that particular time were just horse-drawn wagons and carriages, or in other words, the traffic that they were supposed to carry at that time were just lighter loads. So when the heavy loads such as the railroads came, the strength of the wooden bridges became inadequate to support those heavy loads like the railroads that you are seeing here, thereby forcing the bridge builders to utilize some other material which were the metals that you are seeing here today. So what they did were as their knowledge about the uh, the tension and compression action of each member of the truss, they utilize that knowledge and replace the wooden members of a wooden bridge, especially the tension members, into metal members. So they had replaced the members that were carrying tension forces into a metal member, since as we all know, metal uh, has a very good property in resisting tension forces. So that's what they had done before. They had uh, altered, they had changed the members of a truss bridge or a wooden bridge from wood to metal. And so at that time, they made a hybrid bridge composing of metal and woods. Although as their knowledge about the tension and compression action of each members increase, they also replace as well the members that were carrying compression. And until then, the transition from wooden bridge to an all metal truss bridge came into realization. So other bridge that came through the years are the suspension bridges. So suspension bridges look something like this. Actually, this bridge that you are seeing here is the famous Golden Gate Bridge located in San Francisco, USA. In previous suspension bridges, the roadway was flexible and followed the curve of the ropes or chains. By stiffening the roadway and making it level, James Finley, who was attributed as the inventor of modern suspension bridges, developed a suspension bridge that was suitable not only for footpaths and trails, but for roads with carriages and heavy wagons. So the early suspension bridges that were developed before were all were very flexible. Actually, the famous example of that flexible bridge that were built before is the Tacoma Bridge. So you can search Tacoma Bridge in the internet and you can see that very flexible bridge that uh, that swings even if there is actually no traffic that that is traveling along that bridge, that Tacoma Bridge. So you can see that Tacoma Bridge was very flexible and it swings back and forth even with no strong wind or even with no traffic that was traversing it, until such time that this flexibility became the cause of the sudden failure of this Tacoma Bridge. So this Tacoma Bridge this Tacoma Bridge was one of the failures in bridge engineering and bridge construction that left a very important lesson on bridge engineering itself. So nowadays, the modern suspension bridges like this one, the Golden Gate Bridges, were made as stiff as possible to prevent swinging, as, especially when there is a strong wind, so that the 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 roadway that is being carried by the suspension bridge will be more stable for uh, use of traffic. So the main load carrying member of a suspension bridge is this cables that you are seeing here. So these cables are connected to another cable which transfer the load of the roadway, the weight of the roadway, to uh, the main carrying post that you are seeing here. So that is again another kind of bridge that we had developed through the years. Another kind of bridge that were developed through the years were metal arch bridges such as this. Actually, this is Sydney Harbour Bridge that you can see on in Australia. This is Sydney Harbour Bridge in Australia. Arch bridges are aesthetically pleasing and can be economically competitive with other bridge types. Sometimes the arch can be above the deck, like this one. Other times, when the foundation materials can resist the truss, the arch is below the deck. So sometimes this arch that you are seeing here can be placed below the deck. So this is the deck where the vehicles pass through. So sometimes the arch that is supporting the deck can be placed above the deck or below the deck. Restraint conditions at the supports of an arch can be fixed or hinged, and if a designer chooses, a third hinge can be placed at the crown, which is this point. The crown is the highest point on the arch. A third hinge can be placed at the crown to make the arch statically determinate or non-redundant. So you can see here that through the years, the 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 concept of arch bridges were utilized to develop what we now have as metal arch bridges such as this. So as we have seen on structural theory, on structural analysis, we have seen there that an arch uh, uh, has a very good strength in resisting axial forces. So that's why it's usually used as the main support of bridges, such as this the Sydney Harbor bridges. And arch bridges, metal arch bridges, are not only utilized because of its strength, but also because of its given aesthetics. So usually, the arch bridges, metal arch bridges, give a pleasing appearance that that was the reason why it became popular in the modern highway bridge industry. Another bridge that were invented, another bridge that was invented through the years were reinforced concrete bridges like this one. In contrast to wood and metal, reinforced concrete has a relatively short history. It was in 1824 that Joseph Asdean of England was recognized for producing Portland cement by heating ground limestone and clay in a kiln. This cement was used to line tunnels under the Thames River because it was water resistant. Some concrete arches were built using the pre-stressing construction techniques first developed by the French engineer Ernest Freycinet in the 1920s. So another bridge that was developed through the years are reinforced concrete bridges like this one. So as the name suggests, the bridge is made up of reinforced concrete uh, which is reinforced by reinforcing steel. So usually we use pre-stress construction techniques to build reinforced concrete bridges, especially if the span of the bridge uh, is kinda long. So if we have a long span bridge, usually we incorporate pre-stressing construction techniques for us to be able to construct that long span reinforced concrete bridges. So last bridge that was developed through the years are girder bridges such as this one. So what are girder bridges? So technically, girder bridges are just bridges being supported by girders. So these girders that support the deck of the bridge where the roadway uh, is placed can be made up of concrete or reinforced concrete or pre-stressed concrete or steel material. So that girder can be made up of pre-stressed concrete or reinforced concrete or just steel material. Some of the early girder bridges, with their multiple short spans and deep girders, were not very attractive. However, with the advent of prestressed concrete and the development of segmental construction, the spans of girder bridges have become longer and the girders more slender. The result is that the concrete girder bridge is not only functional but can also be designed to be aesthetically pleasing. So actually in our subject bridge engineering, especially the part of the bridge design, we will be focusing more on how to design bridges of this type, girder bridges which are supported by girder, either concrete girders or steel girders. So we will be focusing more on how to design bridges that are being supported by girders of this kind, either concrete girders or steel girders. Today's highway bridge is an offspring of the rapid development of the modern transportation network. The evolution from the design of new structures in almost assembly line fashion to the detailed design of a bridge rehabilitation did not occur overnight. Indeed, the creation of modern standards and specifications in place today is an outgrowth of the efforts of an entire generation of civil engineers who grew up professionally during the formative years of what was, and still is, the largest public works project in the history. So indeed, the modern highway bridges that we are using today did not occur overnight. Those techniques, those construction techniques, those standards, those specifications that we are using today to build modern highway bridges did not occur overnight. So actually, these are the result of the efforts of those engineers, starting from the non-technical people of long ago, up to the Roman engineers, the early Roman engineers, up to the engineers that we have today. All of their efforts resulted to the bridge engineering that we have today. So the bridge engineering, the designs, the techniques in construction, in designing, the standards, the specifications that we are using today did not occur overnight. They are actually a result of the efforts of those professionals before our time that were forced to design and construct bridges with the little knowledge that they had. So we can see there that indeed bridges, the modern highway bridges, uh, indeed took a long time to develop and to be on where it is today. So, if you want to know more about the history of bridges, you can check out these links that I have provided here. You can check out this link, Engineering History, Bridges, and then this, the history of bridges, and lastly, this, the history of bridge construction. So if you want to know more about the history of bridge engineering, you can check these links that I have provided here.